So, connection between SSLWE and LWE. Okay, so here's a lemma. There is a polynomial time reduction from SSLWE NMQ chi to LWE NMQ chi and one from LWE NMQ chi to SSLWE N M plus N Q chi. So, note that there is the dimensions change. Okay, so one direction is very easy. So, let us say that we have an oracle that solves LWE. So, say that we have oracle to solve LWE. So, this is with the large secret. I want to solve SSLWE. So, I am given an LWE sample with a small secret, and I want to use this oracle or this algorithm which I have to solve it. So, the underlying, so I have let us write it. So, this is my box. I can give it like the standard LWE, okay, and get a solution. This is my oracle, okay, and what I need to do is I have an instance of SSLWE and I want a solution. So, how will I do it? Can you tell me, anyone? I would like you to tell me how to do it. So, my oracle, it only accepts instances of the standard LWE distribution. So, AS plus E, where S and E are, where S is chosen uniformly and E alone is from the error distribution. But what I would like to solve is I want to find the secret from a sample which was generated using the error distribution. Okay, so I have some A t plus E, okay, where this is small. Okay, so the suggestion is can we multiply this with something to make it random. So, that is worth trying, but does it work? I mean, so remember that I am given in my hand AT plus E. If I multiply it with something, the error also gets multiplied with that thing. So, if I and this is really a very, it is really at the heart of the cryptography from LWE, right, the fact that the error blows up. Otherwise, you could always find large vectors that are perpendicular to A and sort of decrypt in that way. So, yeah, so that does not work, but that is a good suggestion. So, something simpler than what you suggested will work. Very good, yes, it works. How? What will you do? Okay, let me take something random. I will take a T prime from ZQ to N. Now, what should I do? What should I add? That is right, that works. So, I have AT plus E, I will just add AT prime to it. This gives me AT plus T prime plus E. So, now this is random, right? So now I can feed it to my solver. It will give me t plus t prime. I picked t prime, so I recover t. That just works. The other direction is much more challenging. Okay, still not very complicated, but now okay, now I have a solver for SSLWE. So this seems harder, right, because I have a LWE sample with a large secret and I want to somehow use a solver which works only for small secrets. Now see, when I am given something small, making it big does not seem hard, but going from big to small is always difficult. So what should I do now? And here a hint is that there will be a loss. So I want to solve LWE, right, for NMQ chi. I need SSLWE for a different dimension. Okay, so it's probably hard to guess. So let me show you. So I have as usual I have AT plus E. Okay. So what I will do is I will write this as A as A1 A2, A1 A2 T plus E1 E2, okay, where what I am going to do is I am going to choose A1 as square and A2 as tall. Okay, so my A here is n plus m by n. Okay, so I write this like this. Now I claim that with high probability A1 is invertible. This is because it is just a random matrix over a finite field. Okay, so with high probability it will be invertible. Okay, okay. So now I write T as or let me not skip a step. So I can write B1 as A1 T plus E1, right. So this is B1 B2. So B1 can be written as A1 T plus E1, and now because A is invertible, this means I can write T as B1 minus E1, right, A1 inverse of this. Does everyone agree? Yeah, good. So now I have T in some form. So now B2, which is A2 T plus E2, can be written as A2 A1 inverse B1 minus A1 inverse E1 plus E2. Does everyone agree? Okay. So I have B2 minus, or let me flip the negative. Okay. So I get A1 inverse E1 minus E2 as A2 A1 inverse B1 minus B2. Does everyone agree? Now this I can compute. Okay. So, sorry, I missed I made a like a typo here. just a second, I skipped an A2 here by mistake, right? A2. So, in opening this out we made a mistake. So, A2 times T, right. So, A2 times T is A2 A1 inverse B1, which we got right, minus A2 A1 inverse E1. So, we made a small mistake here. Okay, good. So, this is A2 A1 inverse E1. So, does everyone agree that we can compute this A2 A1 inverse B1 minus B2, because we have A and we have B. Okay. So, now notice that I can think of this A2 A1 inverse as some new matrix A prime, okay, which I have. So, I have I have A prime E1 minus E2, okay, and this I can feed to the solver. So, my secret became error. My secret in this sample is from the error distribution by definition. Okay. So, now I can feed this to the solver and I will recover E1. Now, once I recover E1, I can compute B1 minus E1, which is A1t, and then I can do A1 inverse A1t and get t back. But you see that there is a loss in dimension. Any questions? There is actually much more that we can do in terms of flexibility in how we choose the secret. In fact, it turns out that the LWE secret, not only is it okay to choose it from the error distribution, it is okay actually to choose it from any distribution with sufficient min entropy. But we will not go into any of that. This I wanted to show because we used this SSLWE in our scheme. You can also construct public key encryption without relying on this variant, but then that needs a little bit more work. Like then you need to define something called as a leftover hash lemma and use that. So, I feel that this is maybe the cleanest and simplest way. So, the public key is an LWE sample. Okay, so now mentally think of that as random, and now my secret key is an LWE sample with respect to the public key, right. So, that is it's also random, and the argument also proceeds very naturally.